So here we have a list of names. Let's write a simple program and check to see if we have a name that starts with J in this list. So we can use our for loop for name in names. Now, if name that starts with J, perhaps we want to display a message like found. Now, if this list has a million objects, as soon as we find the first object, we want to jump out of this loop. We don't want to continue looping for performance reasons. So this is where we use the break statement. You have probably seen this before. When Python interpreter sees this statement, it will terminate this iteration. So now we jump out of this loop. Let's add another scenario to this program. If we loop over all the names in this list and we don't find a name that matches our criteria, perhaps we want to display a different message to the user like, hey, we couldn't find a name that starts with J. So typically how we implement this in other programming languages is like this. On the top, we define a flag like found and set it to false. Then here, as soon as we find an object that matches our criteria, we set this flag to true. And then after our for block, we check to see if not found, we print not found. Let's save the changes. Good. Run the program. Obviously, we have a name that starts with J, so found, beautiful. Now let's change this to A John. Run the program, not found. So our algorithm is working properly. But in Python, there is a cleaner way to implement this scenario. We don't need this found flag. So let's delete it from here and here. All we have to do is to get the same result is to change this statement to else. So we have 4 else blocks in Python. This else clause is executed if our for loop completes successfully without an immediate break. So if we iterate over all the objects in this iterable, then this else clause will be executed. So now, when we run this program, we get the exact same result.